Hello, everybody. We are doing Chapter 2, Graphing Logs. This is Miss Osier.
I'm Miss Lahar.
And here we go.
All right, so first, you got to remember that logs and exponents are inverses. So the table below is y equals 3 to the x. Okay?
See it?
Yep. So that's, one version. So if we were to go to do the log function, we are going to take the inverse. So we're going to flip the x and the y.
Yep, so an inverse is kind of like a reflection over the line y equals x. They switch.
Mm-hmm.
They switch.
So your x becomes 9, your y becomes 2, and so on and so forth.
Your x becomes a third, your y becomes -1, etc., etc.
So you got to remember that technically your y's are equivalent to exponents.
And look at that, they're a reflection of each other. Oh my gosh!
So the one in yellow is the exponential function. Exponential growth, goes up, da-da-da-da. The log function looks like that. Now, if we look at this, what are the possible domain and range?
So remember, domain are all of your x values, ranges are all of your y values. So it looks like, excuse me, on my x, it looks like I'm getting really, 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 really close to the y-axis, but it looks like I'm not kind of going to cross it. So I get really, really close to 0 on the x-axis. I know that's kind of confusing because I'm talking about the y, but I'm talking about the distance there. And then as far as the y goes, this is going on forever. So eventually, it's going to keep rising. So what that means is, for your exponents and your logs, your domain and range are flipped. So with exponents, you can plug in negative infinity to positive infinity into your x. You can plug anything in, and your output is going to be 0 and up. Okay.
But a log for domain, you can't plug anything negative into that x quantity.
Nope.
So therefore, it goes from 0 to positive infinity. But range has no issues. Range can go from negative infinity to positive infinity.
So again, you're saying 3 to what power is x? 3 to something is going to make something magically become negative.
Right.
So that's why your x has to start at 0. Look at us go. Oops, I hit the wrong button. Look at us go now.
Okay, so if you get a more complicated log function, in order to figure out what your domain and range is, it's pretty simple. All you have to do is set that quantity greater than 0.
So like we just said, that part can't be negative. So anything in the parentheses has to be bigger than 0 because that means it's not negative.
So you solve it, and you get x is greater than 4/3. So that's your domain. Range, again, no issues, so negative infinity, positive infinity.
Okay.
Ooh, that's set notation.
Set builder notation just means x such that x is greater than 4/3. It's just pretty. Okay,
It's
you
really
could also
fancy.
do the brackets and parentheses, interval notation. There was, couldn't think of the word. There's lots of different ways.
So I think
Steps for finding domain.
Set x greater than 0 and solve.
When we say x expression, we mean whatever's inside the parentheses. Okay? And solve. Look at us go.
So it's right there. That
Boom.
thing.
That thing right there.
Okay, now, here's where we teach you the calculator trick, and it's called the change of base formula.
Okay, you don't put the 5 in the little space on the calculator where there's a little baby space because it'll tell you that you can't do it because in test mode you cannot. And these will be in test mode. So change of base. Now I'm going to say big guy and little guy. I don't mean their value. I mean the way they look on the screen.
The size
you
of
just
them.
do log of the big guy over log of the itty bitty guy.
So since you're both taking these to a common log expression, so the bases of both those are 10, okay?
It's kind of like dropping the base.
Yeah, it's kind of like dropping the base. So you get the exponent out that you can raise 5 to get 60.
Okay.
That's what it will look like in your calculator. Now remember, the little boxes, those will be blank. Don't fill those in.
No.
Push over to get your 60 and push over to get your 5.
If you put 10 in there, that's fine, but you can leave it blank because remember, it's common log.
Yep. So then your calculator will pop it out, and then you just got to make sure you round to the correct decimal place.
Nearest thousandths. 2.544.
Oh, I got it wrong. Wait, tenths? Hundredths? Oh, I did get it wrong.
Oh, yeah.
So it should be a 4.
You need another 4 right there.
Way to go. Classic. ln is a lot easier because you can just plug that verbatim in your calculator.
Yep, because this is technically ln base e, so ln of 14 over ln e. Well, ln e is 1, so it's just that.
Yep. So it pops
Boom.
out your number, and probably
you
didn't
round
round it
it
wrong again.
To 2.639, everybody.
Now, here we go. Here's that expression. You can't have a negative in there.
Nope, not okay.
So if you see it,
to nothing. It's
don't even
impossible.
put it in your calculator.
Nope.
Just write, not happening.
Or put it in your calculator, have this happen, and then be like,
oh,
it
yeah.
says that there's non-real. Just don't do that. Say, oh, it's telling me that because there's a
No
negative right
solution.
there. So that's no solution.
All right, now let's graph these suckers.
Okay. So it's actually really helpful when graphing if you think about that inverse piece. That will help you a lot. But otherwise, you can just type this in to your graphing calculator.
You see how I left
log
it blank?
Of X over log of 4, left blank, boom.
That's what pops out of your graph.
And then you can go to your table.
Control T and get some points. Now, I've seen graphs lately, not so good.
Oof.
Pick a few good points. So I picked a couple. Look at the good points. I've got 1, 0 is a good point.
There's another
2.5, 4, 1, 8, 1.5,
I like
16,
this one.
2.
I like this one.
Yep.
Maybe, yep.
Yep. Graph the good points. Okay?
Boom.
Now, you connect your dots, making sure that thing, look at how beautiful that is. Make sure your
Arrows.
arrows go down forever.
Forever. It goes forever.
It'll never cross that y-axis.
It's called an asymptote. Ooh. Preview for
Asymptotes.
pre-calculus.
We won't tell you about that. There are lines that you approach but you never touch. Anyway.
Exciting.
Ooh, this one looks a little bit uglier.
But it's okay.
Just remember, be very careful how you plug this into your graphing calculator. I think I show it.
Yep, so we're going to change the base. So log of the big guy over log of the itty bitty guy, and then the minus one's on the outside.
Do you see how I put the log expression in parentheses? You have to be very specific with this because you can't put the minus one next to one of the, in the numerator or the denominator. It goes on the outside. Now, this is what first pops up.
Just show you that again.
Which doesn't really, you have to be able to adjust your window sometimes.
Yes.
Okay, so I went into my window settings, and I knew looking at that expression it would be greater than 16, or negative 16, excuse me. Remember, set that equal to 0, greater than 0, and solve it.
For your domain.
So then that looks a little better, so just so I know where I'm going.
Yep.
And then I picked some good points.
And then I got my good points, and I graph it.
Yep. I should have extended my y-axis, or x-axis,
okay.
but
It's
whatever.
Okay. It's all right. We'll forgive you.
That's how I graph.
All right, ladies and gentlemen, we will see you in class.
Round right.
Oh, gosh, yes.
Don't